chemical reactions, and stoichiometry. Chemical reaction is a process in which a single substance or many substances interact with each other to produce one or more substances. Chemical reactions are represented in terms of chemical equation. Chemical equation use chemical symbols, called formulae of reactants and products. For example, symbol of atomic hydrogen is H. It exists in gaseous state as a diatomic molecule. Therefore, chemical formula of hydrogen molecule is H2. Its gaseous state is indicated by the suffix G and written completely as H2G. Similarly, other gases are represented as oxygen, O2, gaseous; nitrogen, N2, gaseous; fluorine, F2, gaseous; chlorine, Cl2, gaseous; bromine, Br2, gaseous; and iodine, I2, gaseous. At room temperature, bromine exists in liquid state, hence, bromine in liquid state is represented as Br2, liquid, while iodine exists in solid state, and hence, represented as I2, S. Now consider formation of water product from gaseous hydrogen and oxygen reactants. The chemical reaction may be written as hydrogen plus oxygen gives to water. Hydrogen and oxygen are reactants. Plus sign between reactants means reacts with. Water is a product. The arrow between reactants and product means to produce, or to yield, or to give. The above equation can be expressed in scientific manner by using chemical symbols as H2, gaseous, plus O2, gaseous, gives to H2O, gaseous. H2O gaseous means water vapor. Ordinary liquid water is represented as H2O, liquid. The balancing of mass is essential. In above reaction, it appears that mass is not conserved. One molecule contain 2 atoms of hydrogen, reacts with 1 molecule contain 2 atoms of oxygen, to produce 1 molecule of water, containing 2 atoms of hydrogen, and 1 atom of oxygen. Mass of oxygen is not conserved. Hence, the equation is balanced as 2H2, gaseous, plus O2, gaseous, gives to 2H2O, gaseous. The balanced chemical equation suggests that 2 molecules of hydrogen react with 1 molecule of oxygen gas to produce 2 water molecules, as shown in above figure. Chemical reactions and stoichiometry. The starting material, which takes part in chemical reaction, is called as reactant. The substance formed after the chemical reaction is called product from the balanced chemical reaction. It is also possible to determine masses of reactants, and also the products that is formed. Again consider the reaction. 2H2 in gaseous form, plus O2 in gaseous form gives 2H2O in gaseous form. Therefore, in terms of molar mass, 2 moles of H2 plus 1 mole of O2 gives 2 moles of water vapor. 2 multiplied by 2.02 grams plus 1 multiplied by 32 grams gives 2 into whole bracket 2 multiplied by 1.01 plus 16 gram. 4.04 grams plus 32 grams gives 2 into whole bracket 2.02 plus 16 gram gives 2. That is 36.04 grams of reactant gives 36.04 grams of product. Thus, total mass of reactants is equal to total mass of products, and the mass is conserved during the reaction. Stoichiometry is a process of making calculation based on formulae and balanced chemical equations. In the balanced chemical reaction, N2 in gaseous form plus 3H2 in gaseous form gives 2NH3 in gaseous form. 1, 3, and 2 are coefficients of N2, H2, and NH3 respectively. These coefficients of reactants and products in the balanced chemical reaction are called as stoichiometric coefficients. Stoichiometric calculations. The stoichiometric calculations involve following steps. 1. Write correct formula of the reacting substances and also products. Due care must be taken to satisfy valencies of the atoms of the compound. Some of the common compounds are phosphoric acid, H3PO4, sodium phosphate, Na3PO4, ferric phosphate, FePO4, aluminium phosphate, AlPO4, copper phosphate, Cu3PO42, ferrous phosphate, Fe3PO42, hydrogen chloride, HCl, sodium chloride, NaCl, cuprous chloride, Cu2Cl2, cupric chloride, CuCl2, ferrous chloride, FeCl2, ferric chloride, FeCl3, stannous chloride, SnCl2, stannic chloride, SnCl4, hydrogen sulfate, H2SO4, sodium sulfate, Na2SO4, copper sulfate, CuSO4, ferrous sulfate, FeSO4, ferric sulfate, Fe2SO43, etc. 2. Writing balanced chemical equation. Following 3 steps must be followed while writing the balanced chemical reaction. Step 1. Write the names of the reactants with plus sign separating the reacting substances on the left-hand side. Then draw arrow from left of right, and then on right side of the arrow, write the names of all products with plus sign separating products. Thus, in case of a reaction involving burning of the methane in oxygen-producing carbon dioxide and water. Step 2. Rewrite the chemical equation in terms of chemical formula of each substance, as shown below. CH4, in gaseous form, plus O2, in gaseous form, gives to CO2, in gaseous form, plus H2O, in gaseous form. Step 3. Balance the mass of chemical reaction, by selecting the proper whole number coefficients, for each reactant, and product. CH4, in gaseous form, plus 2O2, in gaseous form, gives to CO2, in gaseous form, plus 2H2O, in gaseous form. Write the balanced chemical equation for the reaction between iron and chlorine to form ferric chloride. Solution. Step 1. Iron in solid form plus chlorine in gaseous form gives to ferric chloride in solid form. Step 2. Fe in solid form plus Cl2 in gaseous form gives to FeCl3 in solid form. Step 3. 2Fe in solid form plus 3Cl2 in gaseous form gives to 2FeCl3 in solid form. This is the balanced chemical reaction. Write the balanced chemical reaction between aqueous solution of ferric chloride and metallic zinc. Solution. Step 1. Ferric chloride plus zinc gives to zinc chloride plus iron. Step 2. FeCl3 in aqueous form plus zinc in solid form gives to ZnCl2 in aqueous form plus Fe in solid form. Step 3. 2FeCl3 in aqueous form plus 3Zn in solid form gives to 3ZnCl2 in aqueous form plus 2Fe in solid form. This is the balanced chemical reaction. Express the interaction between aqueous solution of ammonium phosphate with aluminium sulfate with balanced chemical reaction. Solution. Step 1. Aluminium sulfate plus ammonium phosphate gives to aluminium phosphate plus ammonium sulfate. Step 2. Al2SO43 in aqueous form plus NH4 in aqueous form gives to AlPO4 in solid form plus NH4 in aqueous form. Step 3. Al2SO43 in aqueous form plus 2 NH4 in aqueous form gives to 2 AlPO4 in solid form plus 3 NH4 in aqueous form. This is the balanced chemical reaction. Mass relationship. A balanced chemical reaction may be used to establish the weight relationships of reactants and products. This is based on law of conservation of mass, which states that total mass of reactants is always equal to total mass of the products. The mass relationship is illustrated with the help of following balanced chemical reaction. Atomic masses, Fe equals 55.85 U, Cl equals 35.45 U. 2Fe in solid form plus 3Cl2 in gaseous form gives to 2FeCl3 in solid form 2 atoms of Fe, 3 molecules of Cl2, gives to 2 molecules of FeCl3. 2 into 55.85 grams, plus 3 into 35.45 into 2 grams, gives to 2 into whole bracket 55.85, plus 3 into 35.45 grams, 111.7 grams of Fe, plus 212.7 grams of Cl2, equals 324.4 grams, equals 324.4 grams of FeCl3. Hence, the mass is conserved during reaction. Calculate the mass of carbon dioxide and water formed on complete combustion of 24 grams of methane gas. Atomic masses: C is equal to 12 U, H is equal to 14 U, O is equal to 16 U. Solution. The balanced chemical equation is CH4 in gaseous form plus 2O2 in gaseous form gives to CO2 in gaseous form plus 2H2O in gaseous form. 12 plus 4 gram. 2 multiplied by 16 multiplied by 2. 12 plus 32. 2 multiplied by whole bracket 2 plus 16. 16 grams of CH4. 64 grams of 2O2. 44 grams of CO2. 36 grams of 2H2O. Hence, 16 grams of CH4 on complete combustion produce 44 grams CO2. Therefore, 24 grams of CH4 is equal to 24 upon 16 multiplied by 44 is equal to 66 grams of CO2. Similarly, 16 grams of CH4 produce 36 grams of water. Therefore, 24 grams of CH4 is equal to 24 upon 16 multiplied by 36 is equal to 54 grams water. Calculate the number of moles of methane required to produce 66 grams of carbon dioxide gas on its complete combustion. Atomic masses: C is equal to 12 U, H is equal to 1 U, O is equal to 16 U. Solution. The balanced combustion chemical reaction is CH4 is aqueous form plus 2O2 in gaseous form gives to CO2 in gaseous form plus 2H2O in gaseous form. 12 plus 4 plus 2 multiplied by whole bracket of 16 by 2 gives to 12 plus 16 multiplied by 2 plus 2 into whole bracket 2 plus 16. That is 16 grams of CH4 plus 64 grams of 2O2 gives to 44 grams of CO2 plus 36 grams of 2H2O. For 44 grams of CO2 is equal to 16 grams of CH4 is required. Therefore, for 66 grams of CO2 is equal to 66 upon 44 multiplied by 16 is equal to 24 grams of CH4. Hence, number of moles of CH4. Mass of CH4. Bond molar mass of CH4 is equal to 24 upon 16 is equal to 1.5 moles. Limiting and excess reactants. For a given chemical reaction, the amounts of reactants required or products formed are based on stoichiometric coefficients of products and reactants of the balanced chemical equation. Generally, as a cost-saving measure, the cheaper reactant is taken in excess, and costlier reactants are used in lesser amount. The reactant that is taken in lesser amount gets consumed earlier and the reaction stops. Hence, the reactant, which is taken in excess, an appropriate part of it is utilized for the reaction, and remaining part of it remains with the products of the reaction. Therefore, the reactant taken in inadequate quantity is called as limiting reactant. It is the reactant that reacts completely, but limits further progress of the reaction. The excess reactant is the reactant which is taken in excess than the limiting reactant. Hence, some amount of it remains unreacted. The idea of limiting and excess reactant is made clear with the help of following problem. Gold reacts with chlorine at 150 degrees Celsius as per balanced chemical reaction. 2Au plus 3Cl2 gives 2AuCl3. 10 grams of each gold and chlorine are sealed in a container and heated at 150 degrees Celsius till the reaction is complete. Name the limiting and excess reactants. Also calculate amount of AuCl3 formed and mass of excess reactant left behind. Atomic masses. Au is equal to 196.97 U. Cl is equal to 35.45 U. Solution. The reaction is 2Au plus 3Cl2 gives 2AuCl3. The stoichiometric coefficients are 2, 3, and 2. That is if 2 moles of gold are reacted with 3 moles of Cl2. Then on completion of reaction, 2 moles of AuCl3 will be obtained. Now, 2Au plus 3Cl2 gives 2AuCl3. Theoretical amount 2 multiplied by 196.97 grams plus 3 multiplied by 35.45 multiplied by 2 gives 2 into whole bracket of 196.97 plus 3 multiplied by 35.45. That is 393.94 grams plus 212.7 grams is equal to 606.64 grams of reactant is equal to 606.64 grams of product. Ratio of moles of reactant. Au is 2, Cl2 is equal to 2 upon 3 is equal to 0.667. Actual amount 10 grams of Au and 10 grams Cl2. 10 grams upon 196.97 is equal to 0.0508 moles of Au, and 10 upon 70.90 is equal to 0.141 moles of Cl2. Ratio of actual moles of Au is 2, Cl2 is equal to 0.0508 upon 0.141 is equal to 0.36. Theoretical ratio of mole of Au is 2, Cl2 is 0.667. Actual ratio of moles of Au is 2, Cl2 is 0.36. Hence, Au is limiting reactant, while Cl2 is excess reactant. Now, 2 moles of Au require 3 moles of Cl2. Hence, 0.0508 mole of Au require 0.0762 mole of Cl2. Moles of Cl2 remaining is equal to 0.141 minus 0.0762 is equal to 0.0648 moles of Cl2. Mass of Cl2 reacted is equal to 0.0726 multiplied by 70.90 is equal to 5.402 grams. 70.90 grams is molar mass of Cl2. 2 moles of Au produce 2 mole of Au Cl3. Hence, 0.0508 mole of Au produces 0.0508 moles of Au Cl3. Hence, mass of Au Cl3 produced is equal to 0.0508 multiplied by 303.32 is equal to 15.409 grams. Au Cl3